Hi everybody, we're recording this quick video to remind everyone how to work with our Atom Maker experience. The Atom Maker experience is created as a series of scenes, and the teacher controls those scenes. The teacher allows to take the whole audience with him or her from one scene to another. We are right now in basically an intro scene where everybody comes in at the beginning of the class, and here teacher can talk about the periodic table, basically click any elements, show different kinds of orbitals, and everything that teacher talks about is replicated, supersized above him or her, and students can raise their hands, ask questions. They have their own periodic tables to play with. But this is really a room where everybody, the whole class gathers before the lesson. To see how the actual creation of elements and the atoms happens, we need to go to the next scene. Let me click the next button. We appear in the scene where students, they're sitting in a circle that goes all around the teacher, right? And each and every one of them can work with their individual atom makers, and everybody can see everybody's progress. And the whole experience has a very engaged class when you are basically in a way competing with your peers, but at the same time encouraged by their progress. Now, as a teacher, I can, for example, select an element. Let's go with cobalt. Boom, I open up Cobalt, and what I see in front of me is this big atom-making machine, right, from which I will be assembling Cobalt. Now, again, everything that I do is replicated, supersized above me, and I can see various ways how I can look at the element of the periodic table. Now, let's go ahead and try to assemble Cobalt. First, we have this tool on the right-hand side that we call an elevator. You can drag this ball and go across various energy levels of an atom. You're starting from the nucleus and go to the first, second, third, and as you go to a new energy level, it opens up all type of orbitals that are available for this particular energy level, right? And here students can click through all the orbitals, S orbital, all the p orbitals, all the d orbitals, and they basically need to be filling all of those orbitals with particles, in this case with electrons. But once we are on the nucleus level, we need to first put some protons and neutrons into the core. Now, for the cobalt, we see that it's has 27 protons, and here is a counter that will be counting how many protons we put into it. So what you need to do, you just basically point your controller at the nucleus and start shooting, and you can just click and hold the trigger button, and it fills all the protons into the nucleus. And if you put, for example, too many, I put 29. You see, like all of this is replicated, supersized above me. I put 29. My other arm works basically as a vacuum cleaner. I can remove unnecessary protons. So I need to put 27 protons. Here is 27 protons. The next thing we need to do is to put some neutrons, right? Let's switch controllers to neutrons. Here we can see the neutrons now. And now the formula suggests to us how many neutrons we have to put inside. So 59 is atomic weight minus 27 atomic number. We're going to add 32 neutrons. Now let's start shooting neutrons into the nucleus. And here we go, and they glue together. And as you're putting neutrons, you can see how the protons and neutrons, they start to clump together. Now we put like way too many. It's 40. Let's remove some of the neutrons, and 32. Good. So now the nucleus is done. Now let's go energy level by energy level. First, we move to the first energy level, and it shows us the full description of what we have to put on each energy level. 1s2, 2s2, 2p6, 3s2, and so on. Now, so the students who learn chemistry, they can understand this. They can see that you need to go to the first energy level. For the s orbital, put 2 electrons. Then automatically it switches to electrons as I'm moving to the various energy levels, but I can of course switch to other particles if I need to. Let's keep it on the electron side. So let's put 2 electrons on these s orbital. You see how it flies around a little bit kind of unpredictably. The electron is here, but at the same time it's in a few other places. So that basically shows this kind of a nature of electrons, that it is present at the same time in multiple places. Now let's go to the second energy level. So here our formula says 2s2. We need to put 2 electrons. The next is 2p6. So for the p orbitals, we need to put 6 electrons. Again, as chemistry students know, the maximum number of electrons you put per orbital is 2. So 2p6, meaning that each orbital needs to have 2 electrons. Let's start putting them. 2, 2, 2. So we have 2 electrons at each on each orbital. Now I can click through them. You see they're highlighted with a slightly different color, and they say that, hey, you just filled this orbital with electrons. Now let's keep going. 3s2. We go to the third energy level. s2, s orbital, 2 electrons. 3p6, again the same thing. The p orbitals, we need to put 6 electrons again, which means 2 electrons per orbital. 6. You see, when I'm putting too many, it just flies through. So it's really easy when you get a hand of it to basically keep filling these electrons pretty rapidly, which actually helps with your class to run faster, especially when you get to the point of the experience where students compete with each other, who is the first to assemble a particular atom. Now, so we've put 3p6, now 4s2. Let's go to the fourth energy level, s2, s orbital, and we put 2 electrons. And the last one, 3d7. Now we go back to 3d. This is d, and 7. So 7, we know that there are 5 different orbitals, d orbitals, for the third energy level. But we're not putting here 10 electrons. We're putting just 7 electrons. Now here the students need to remember how exactly you're putting electrons on each orbital. Actually, the correct way to put electrons is not like I was doing it with the p orbitals or with p orbitals, but just shooting them all, like 2 on these, 2 on these, and 2 on these. In reality, to fill it up correctly, you need to start filling 1 electron per each orbital, and only once you fill all 5 orbitals, you start adding the second electrons from the beginning to those orbitals where you can fit them in. So let's start filling them. So on a d orbital, 1 electron here, 1 electron here, 1 electron here, 1 electron here, 1 electron here. That's 5. We need to put 7. So we go here, we add 1 more and 1 more. So that would be 7. Now let's make a mistake. Let's fill 1 here, and I don't know, randomly let's put like 2 electrons here. Once we have filled our whole electron, we press the commit button, and you see we've made this mistake, and mistake highlights where exactly the problems are. So I can go to the third energy level, and I say, hey, there is something wrong with the with this orbital. Now I know what's wrong. I added unnecessary electron here, and then I can go to the 5th energy level, which is not even in my formula, but I know that I added some of the electrons here. By the way, they also highlight, the mistakes are also highlighted over here, and I can remove this and remove this one. Now everything looks correct. Let's try to press the commit button again. Whoop! Once we assembled everything correctly, it shows how we create an atom, and the atom is done. Now we can click the haptic button and basically drag the atom around to make sure students don't create a mess with those atoms and don't just throw into each other. If you release an atom, it kind of gradually moves into its original place. And if you want to remove all of these visuals in front of you and make sure you can see everybody else around, you just, hide it and then unhide it. So this is how you create atoms in our Atom Maker. In the next videos, we'll remind you what kind of games we have in the experience and how students can compete and cooperate with each other, gamifying this experience, which helps them to remember the periodic table and the creation of atoms better.